everyone to, if they could please give a warm welcome to Kevlin.
And this is the bit where it all works? Oh, yeah, there you go.
Yay.
Brexit Britain. That's what it looks like. Yeah, that's what we call summer. Okay, so, right, what are we going to talk about? We're going to talk about this. So, we don't know if the food is going to be out there, but I presume the drinks might be.
Let's hope so.
Let's hope so. Right. Well, this, so I'm standing between you and some free booze. Excellent. That's, and back to the Twitters, the hashtags and all the rest of it. That my parents gave me a sufficiently internet unique name, so it's always. Which I think was impressive, given the internet didn't actually exist at the time. But do think of this for your children. It is a gift you can offer them. I've done that for my kids. And it's about a decade and a half in the making. I did Google their names, but it's the fact that the older one, it's just like, Dad, what shall I use? I said, just use your first name, last name. Oh, it's available. Yeah, I know. And the same for his domain name, and it's just like, that is how you get gratitude out of a teenager, in case you were wondering. I was really excited by the crash possibilities, except for the fact that they're teenagers. Otherwise, it's just like, yeah, look, just go and play with the other kids. Come down to Perth. Well, last time I went through a place called Perth, it was a lot colder. It was on the way to Dundee, and I had exactly the same problem as I have here. I kept driving or looking the wrong way when I crossed the road, because I got so used to the fact that airplane means other side of the road. Airplane means other side of the road, and I get that every time I come to Australia. It's just, oh, I've got in the wrong side of the car. It's just like, yes, but you're British. I know, and everywhere else isn't. So therefore I've learned this is a reflex. Now, cars are relevant. We are going to talk a little bit about cars. We're going to talk about speed, and I want to deal with some false equivalencies, some myths, and so on. And I also need to do a sound check. The only reason I'm wearing this mic is for that recording over there. Can everybody hear me? That's a really stupid question. Raise your hands if you can hear me. And therefore the people, I'm looking for the gaps at the back. There we go, we're good. Okay, so Sam mentioned I've done stuff with patterns. That's also, I only show these pictures just to show there's evidence of sunlight in Britain. I quite like photography as well as writing flash fiction, and my kids have got used to the fact that whenever there is even the slightest, remotest hint of sunshine in Bristol, I will race through the house with a camera and a bunch of books trying to get good photographs. Yeah, otherwise they all come out black and white, yeah, and very grey. That's the 97 things every programmer should know. In theory, we're working on 97 things every Java programmer should know. Again, watch Twitter. We'll see what happens with that one. But that will be an open call. Contributions to that, it's for anyone. Okay, so if you feel that you have 500 words to say on various things related to the Java ecosystem, then that may be for you. However, we're not really going to talk about that. We're going to talk about this box that was delivered to me a couple of years back, and I just thought, they cut the tape in just the right place, so I want to talk about this stuff, and where better to go than the dictionary? Oh, you want to take a photograph of that? Go for it. Go on. Yeah. So Concise OED says that Agile is an adjective, which is a good start. It means it's a property of something. Okay, it's not a noun. You can't do it. You are it or are more of it. In other words, yes, we are more agile or less agile than we were 6 months ago. That team is more agile than that team. We can even apply it to the artifacts that we work upon when we realize what it actually means, able to move quickly and easily. So we can say of our code base that it is agile. Are we able to move it quickly and easily? And this is one of the biggest causes of friction, where you have a team that's kind of like, yeah, we've got agile mindset, and you've got a code that goes, The code refuses to be moved easily and quickly. Okay, so there's this notion of alignment there. But there's a couple of things here. This is a really simple definition, and yet it's not simple enough for some people. For many people, they reduce it to just that. They forget the easily bit. Somehow we just lost a whole dimension of complexity and possibility. And this comes back to the fact that a lot of things that we advocate, when we talk about good practice or good process, they are in some sense hard. And we can go right back to Blaise Pascal and his provincial letters. I made this letter longer than usual because I have not had time to make it shorter. The internet gives you all kinds of citations for this one. They're mostly wrong unless they are Blaise Pascal, because the original French was this. He didn't say it in English, and I found the original French, so we do know that there's that. But the most interesting thing here is that this takes effort. All of these things take effort, and we'll come back to the sizing aspect and its relationship to agility a little bit later. But really at the moment, the thing I'm really interested in is this question of time. It turns out as human beings, we are terrible at dealing with time. We have very poor sense of time. We have very poor judgment over time. The whole 2008 credit crisis came about because of what's called poor intertemporal judgment, which is a fancy way of saying people just have no idea how to invest for the present versus the future. And I'm talking about the financiers here, not the public. So we are very, very bad when it comes to time. We're very bad when we talk about it in terms of estimation and things like that. We'd like to think we're good at it because we exist in it, but actually it turns out that there's a lot more subtlety to it. It also tells us something else. It's to do with what we value. And the problem is that sometimes when we start talking about things like value, which I'll come back to later, turns out you have to understand somebody's value system to understand what's going on. So the Northern Irish football player, George Best, this is one of his more famous quotes. I spent a lot of money on booze, birds and fast cars. Again, I said cars will be coming up. The rest I just squandered. Now here you immediately see a representation of a person's value system. And the point there is that that on its own gives you a very different story to that. Okay? And it is this question of understanding how people relate to time and how they relate to value, how they relate to their own experience. So this is a replay of kind of an interesting conversation I had with a developer. We're doing some Python. I can't get this code working. Did you check it before integrating it? Yes. Checked it in the interpreter. No. Did it work there? No. Yeah. It's like, it's just like, what, how? What we see here, again, going back to that personal sense, is this reveals the sense of optimism that people in software development have. This unconditional optimism. Well, it didn't work there, but maybe it'll work there. Maybe it didn't work on my machine, the opposite of the usual one. It didn't work on my machine, maybe it'll work in production. What a great idea. And honestly, the people who are in software development are optimistic, otherwise they simply wouldn't do it. There is always that sense that perhaps, just perhaps, this will all work out, contrary to all the evidence that has been presented to us. But this forms part of a culture that best captured by this. And yes, that is intentional, because this is what happens when you move fast. You do break things. And the problem is, this is an engineering maxim which has its place, but it's never presented with a boundary, as Facebook have recently demonstrated. The point here is that if you're breaking something, whose thing is it? And are you going to fix it? You know, it all sounds very, this is all this kind of programmer nonsense. Okay, this is all very brash and there's a lot of macho nonsense tied up in this. Honestly, this is not how I want to develop. But we have this obsession with speed. Now, this is the interesting thing, because we do have an obsession with speed, but sometimes we hide behind other words. We hide behind words like velocity. We can actually blame Kent Beck for introducing the term velocity to the Agile space. A lot of people think it's a Scrum thing, but actually it came from the original Extreme Programming book, XP Explained, so 1999, and has been incorporated into a lot of discussions and Scrum approaches. But the term is used interchangeably with speed, and I struggle with this because somewhere in my past I have a degree in physics, and these two are not equivalent. Okay, this notion is that there is a sense, there is direction. Okay, it's not just a magnitude, it's not just an amount, it has a direction as well. That direction matters immensely. The problem is that what we're getting from most teams, most reporting structures, most metrics is speed. We're not getting velocity. You know, we're heading in the wrong direction at great speed. How are we doing? Oh, we're going really fast. Yeah, but shouldn't we be heading that way? Doesn't matter. Look at the speed on that. So, you know, it reminds me of a time when I was driving from Brussels airport, trying to get into Germany. Brussels is surrounded by a ring road. Now, one of the interesting properties of ring roads is that they are circular, which means that all signs point to all directions. Now, if you're on a long straight road, you can normally sense which direction you're going in, but given that actually every single sign had signs to pretty much everywhere in Belgium, north, south, east and west, I wasn't getting any help here, and this is just before I got a sat-nav as well. And it was only when I realized the sun was in the wrong place that I was heading in the wrong direction. And this is this notion. I was driving at great speed. Obviously, once I got across the German border, that was great because they don't have a speed limit on the Autobahn. But it turns out that driving at great speed without the right direction is not the point. I would have been better off walking for most of that journey. And this is huge, this idea of, are we moving in the right direction? That tells us that we have to navigate. That tells us we have to take our bearings. And I don't care if that takes a bit of time, because honestly, that's time saved. So we focus on the magnitude. Magnitude is displacement with respect to time. What is S? Well, fancily speaking, let's just keep it simple. My kids are doing. Actually, no, the older one's just doing this one. The younger one's just doing this one. What is S? S is distance. Okay, let's talk about this in terms of software. S is stuff. Now stop me if I'm being too technical. Because what we're talking about here is the amount of stuff per time. Okay? We want to measure that. Okay, amount of stuff per time. So we're going to drop any pretense of velocity, we're just going to go for speed. We're going for a magnitude. People are often presented with idealized burn down charts, which look like this, which always worry me a little bit because there is a sense here that if you are dealing with something, if you are dealing with the development of something which you do not know everything about, then this is probably not the progression you want. You probably want a start slow, speed up progression. Oh yeah, now we get the idea. Oh yes, now it's all coming together. In other words, it should look more like that. And there is this notion that that profile is idealized, and it does serve a purpose, but I tend to prefer, rather than burn downs, I prefer build-up charts, which is how much stuff have we built. And honestly, if you can combine the two, you can get cumulative flow diagrams, but that's a different discussion. But I'd like to know how much stuff we've actually built. And this is a build-up chart, although for reasons that escape me, except symmetry of language, people often call this a burn-up chart. And honestly, I'm thinking that's a really bad metaphor to be going with. You know, when my kids are small, burn-up meant they've got fever. Okay, this is bad. You know, likewise, I'm really into space travel and stuff. Again, burning up, bad thing. Yeah, it's got bad written all over it. So I prefer build-up because quite literally it is more constructive. How much stuff have we made over time? Now, that's fine, except we are challenged at some point. Somebody has to tell us, what is it that we're measuring with stuff? And the ideal version is value. This is a phrase that gets thrown around, but the problem with that term is that if you kind of scratch it, it turns out there's either not a lot there, or what you think is value is not somebody else's value, going back to the George Best quote. And sometimes an obsession with value falls into, particularly when we start talking about financial value, it falls into the same trap as pursuing any other metric blindly, like speed. This cartoon characterizes this. Yes, the planet got destroyed, but for a beautiful moment in time, we created a lot of value for shareholders. And honestly, sometimes the way that the software is developed, you can't get that sense. But there's something else here that we need to be very careful with. We need to be very careful with our language. People often talk about estimation or prioritization. These two things kind of go together, but sometimes you forget that you can have an estimate of a priority. The reason I say this is because people often talk about prioritizing their features, their backlog, with respect to business value. I'm here to tell you that you can't do that. Okay, it's actually a physical impossibility to prioritize your backlog with respect to business value. Because with respect to the laws of physics, you need time travel. Because you do not know the business value of something when you are building it. You only know after the fact. So unless you actually have a time machine, you cannot prioritize by business value. And if you have a time machine, what the hell are you doing here? I mean, there's some dinosaurs to be checked out, okay? But this is important because what it does is it shifts our vocabulary again to something a little more honest. Speed and velocity are not interchangeable terms, or rather, by understanding the difference, we actually reveal a gap. This is important. You can prioritize by estimated business value, but you put that estimated word in there and it suddenly makes everybody a little more cautious and a little more open to discussion. We're estimating, how are we estimating it? How wide are the error bars on this? You know, you kind of take a little bit of edge off the false confidence. You prioritize by estimated business value, which, if you're going to do the right thing, means you need to go back afterwards and see, well, how did our estimates work out? People often talk about estimates of time as the thing they want to calibrate, but honestly, it's all open to this. So we go back to this, and there's still a question. We have an answer. I mean, we know that T is measured in time, but what is stuff measured in? I mean, if we're not measuring it in terms of business value, because we don't know this at this point, I mean, is that line of code, is that feature, how can we say how much value that is? Because by the time you start drawing the error bars on it, your diagram gets very exciting and very interesting and almost entirely useless. So what we do as human beings is we find the thing that we can measure. And people often end up, okay, well, what we're going to do is we're going to measure this in terms of, I don't know, story points or something else. And then when eventually what you realize is that you're measuring time against time. This used to be a little more obvious. A number of years ago, sort of 2006 to 2008, the Scrum Alliance was keen on talking about you should estimate your backlog in hours. And honestly, I can't, you know, I can barely understand what I'm doing in a day in terms of the hours. The idea of, and that's when I'm there, the idea of being able to do this for a thing that I have not yet built with a group of people, well, I'm pretty sure that doesn't undermine my confidence that we collectively can do it, but the conversions back to how many hours this is going to take, that's kind of dangerous. So we end up with a measure of how much time are you spending against time. And I remember pointing this one out to somebody and they go, oh, I had not realized that. And I said, yeah, you're effectively measuring, the way you've done your calibration, you're measuring hours against day. And I said, this does mean something. It's called utilization. But that's probably not what you are measuring. If you are trying to say how much stuff are we getting developed, then that's a very different thing. You may also be calibrating quality of estimation. That is also time against time. But neither of these is how much stuff have we developed. So this tells us that we do need to slow down. And there's, so a friend of mine, we do a number of workshops together, and he's written some really decent, he's written a really decent open source tool, Cyber Dojo, for doing test-driven development. An absolutely brilliant environment. I use it a lot. John Jagger, he mentioned this one to me a few years ago. The OODA loop comes from John Boyd, US Air Force pilot. The funny thing about software and business is that eventually all military metaphors find their way into business and into software. The 1990s, everybody was obsessed with Sun Tzu's The Art of War. And so you can kind of go through these business cycles. What military fetish are we following this decade? But there was some really interesting stuff about John Boyd, and one of them was that he was dealing with fighter craft, and this notion of high velocity engagement. And it's not like Top Gun, certainly not with the hair and the 80s soundtrack. There is this idea that it's kind of like fly by the seat of your pants type stuff, and it's all instinct and all this kind of stuff. It's not like that at all. There's an awful lot more intelligence that goes into this stuff, and one of the standard strategies that he established was this idea of just look around. Where you're, you need to look, get the information. Where are you? Where do you want to be? here, here. Okay, so this immediately tells us that even if we're going to stretch the metaphor, there's a sense of direction here. Okay, and then you have to make a decision. You have to decide on your plan of action. And then finally you do the bit that you see in the films. But there's this notion that there is a whole process that is effectively invisible from the outside that is about reflection. Now I'm going to flip this through 180 degrees, not gratuitously, but because it turns out when John and I were putting together a workshop a few years ago, John likes the OODA loop. I like PDSA. It was when we were, which ones we put in, and it was only when I was looking at them I said, wait a minute, these are the same. Oh, that's interesting. The word act means something slightly different. They're in different positions, but the logic of each one is identical. They just start from a different point. It's just that's kind of interesting. There's this simple idea. Plan. And then do. And then the hard bit. Because you see, a lot of people get stuck with this. So first of all, some of my kids asked me, I think my younger one, Dad, how did you develop on computers, back in the 1980s? Trying to work out how you did this without the internet. And why would you develop software if you didn't have an internet to connect to? There was a motivation question there as well, as a capability question. And I say, well, honestly, particularly home computing, it was just sitting at home, you just do. There's an awful lot of doing. And that just turns out that doesn't scale very far, but wow, it's great fun. And then eventually somebody teaches you the value of planning. Now here, when I use the word planning, I'm not talking Gantt charts or anything like that. I'm just talking about having a set of ideas about how things are arranged. Now the word plan has two meanings. One of them is the idea of a building plan, a spatial arrangement. The other is a temporal plan, things happening in time. Fortunately, thanks to Einstein's theory of general relativity, these were both unified under space-time. So that's what I mean when I say plan. It's a bit of both. So how am I going to go about doing this? What kinds of things do I want here? Not necessarily a grand plan, but there's the idea of here's what I'm going to do. Now the problem here is that then people fall into the next trap, which is the grand plan trap. Which is, hey, we're going to do all of that on the left-hand side. Plan, 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 plan. Do, 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 do. And do-do is pretty close to what you get. And then eventually somebody says, you know what, maybe there's something a little more iterative to this. Maybe plan, do, plan, do, plan, do. And that kind of spreads the butter more evenly. This is more raspberry jam than strawberry jam in that sense. But those are the visible things. I can see the outcome of a plan. Either it's kind of like, here's what's going to happen in time. I can see, I can see how we might have chosen to do things in this sprint, then this sprint, then this sprint. And I can see the arrangement of code. And I can see the doing. I can see the tests. I can see the check-ins. These are all highly visible. And again, as humans, we are easily distracted by the things we can see. The things that we can't see, those are hard. So therefore, it turns out the bottom half of this is the bit that people struggle with. This is actually where the agility comes from. It's not the top half, it's the bottom half. Because the agility is about the movement. It is about the moving easily. But there must be movement, not just always in a straight line. And so there is the third stage, study. Now sometimes this is called check. Plan, do, check, act, PDCA. I prefer the original formulation that comes from Shewhart, and Deming used to use this one as well. Study. For a very simple reason. It sounds slower. Just think about the two words, check and study. Which study? Okay, we're going to have to take some time here. My older boy did some exams last year. My wife and I did not recommend that he check his work. We recommended he study. Yeah? Checking is the thing you do at the end of the exam. Oh, quick check. It's quick. Okay, there you go. Haskell reference as well. So quick check, it's cursory. It doesn't suggest depth. It might be necessary, it might be helpful, but I want to slow down. It turns out that this is the bit that people don't want to hear, the slowing down bit, but we want to go faster. Yeah, you might want to slow down a bit. Look at what's happened. Look at what you expected. And then make a decision as to what you're going to try next. It may not work out. And this, I think, is really important because what we're doing here is formulating and evaluating hypotheses. Your plan is not a strong commitment. It's what are we going to do next? I don't know. I believe this should work. Okay, show me. That's the do. I've formulated a hypothesis. Now I'm going to run an experiment. Although clearly using this language, although it's accurate, is toxic in a business environment. So how's your team doing? Oh, we're running an experiment. What? We're expecting deliverable software at the end. Yeah, it's a big experiment, man. It's like, oh, but it is an experiment. But if you think of it in those terms, here's our hypothesis. We believe, given our current knowledge, our current understanding of the requirements, our current skills, our current tooling, with this current team, that we can deliver this amount of functionality, these particular features in this period of time. That then comes the show me. Yeah, that's great theory. Let's actually put this into practice. And then you have to study the results of the experiment. And then there's suggestions for further work. Okay? The life cycle works really well. It really works very nicely. So you may want to change the words, but unless you happen to work in an environment where experiment is perfectly acceptable. And a lot of people go, well, yeah, but the plan vision we were given, when we were told the plan, it was all part of our software engineering education. I have some very bad news for you. Software engineering was not to blame. The waterfall cycle was not to blame. So here's the proceedings of the 1968 NATO-sponsored software engineering conference in Garmisch, Germany. And this is often cited as being, it's most famously cited for and credited with the term software crisis, which honestly is discussed in about 2 pages of the proceeding. I've read the whole proceedings. It's a page or 2 there, software crisis. And there's a couple of other things that people credit it with. They also credit it with the invention of the term software engineering. That's not true. It was a woman called Margaret Hamilton who basically saved Apollo. It was her nice insight. You know those bits where people say, that'll never happen, we don't need to write code for that. She asked the question, what happens if this happens? And that'll never happen. Yeah, it might do. So she wrote code for this brilliant piece of fault tolerance, one of the first avionics systems to exhibit this kind of behavior. If you know anything about the Apollo landings, the 1202 era, this is this. If you watch First Man, this features. So she came up with the term software engineering, and it was already in current use by the time this conference came around. But it's worth actually going back and instead of reading what other people think they said, actually reading the document. This is one of the great things about the internet, you can find pretty much anything. So I did sit down and read it, and I was quite amazed at what people were saying. They did not necessarily speak with one voice. There were a lot of different voices at this conference. But they said crazy, wild, out there things like the design process is an iterative one. Whoa, that'll never catch on. And it wasn't just Andy Kinslow that was saying it. This, I actually had to delete, for one of my talks, 1968, I actually had to delete a whole load of the quotes because I suddenly realized this is going to get monotonous if I quote everybody who basically said this. But this was a recognition back in the 60s. This was known. This whole idea of, oh, we're going to plan everything up front, that was dismissed in the paper, in the proceedings. So there is a point here about what we're doing. So I'm going to quote one of my favourite authors. Sam mentioned that I write fiction, so I also read it, and one of my favourite authors is Neil Gaiman. You have to finish things. That's what you learn from. You learn by finishing things. There's this whole idea that one of the reasons that iterative structures work is because, oh, let's try this. How's this going to work out? Well, that worked out better than expected. Oh, that worked out terribly. I'm glad we didn't overcommit. There's this idea, you learn things. It's a lot easier to see something once it's been shipped out or parceled off in some way, or you've done a demo or you've got a customer using it. So you can point to it and go, I can see where we can improve that. But if it's not there, you can't point to it. You don't have that closure that is necessary to say, oh, okay, now I've learned something. Yeah? So there's a learning cycle here. So there's an empirical and a learning cycle. And part of that is going to involve refactoring. I need to take a new picture because Martin's come out with a second edition. The problem is we haven't actually had much sunlight in Britain, so I'm still stuck with the old picture that was taken a couple of summers back, so I'm waiting for the sunshine. My wife suggested there might have been some the other day, but I think that was just vicious rumour. But what we're talking about here is looking after this stuff. There is a cycle here that is producing what? Well, let's talk about code for a moment. When we talk about code, what people are talking about in many cases is the code that they like, the code that's in their language of choice. Okay, and so if you get a Java programmer, you're going to say, okay, so let's talk about the code. That will be the Java code. All that XML that actually holds the system together. There's a reason that a few years ago when Sun were pushing 100% Java, that stopped really fast because there is no such thing as a 100% Java system beyond Hello World, because it turns out that everything's held together with XML. Yeah? Because apparently it's human readable for some very strange class of humans. And then you kind of go through and you go, oh, well, there's JSON, there's XML, then we've got to build scripts, and then there's the groovy stuff that does the builds, and then, oh, it's a lot of stuff. It turns out, oh, and then there's the test, but we don't worry about those. It turns out the tests, your scripts, your configuration, these are all code. Yeah? We just have a kind of like, oh, I am a Java program as opposed to I am lost in XML land. There's this idea like that this is all code, I'm afraid to say. But there's another way of looking at this stuff. A few years ago I started playing with the words a little bit. Realized actually this is a really good representation. Code is codified knowledge. Here is what we as a team collectively believe. Here's our current way of bringing these technologies against these requirements together. This is it's a knowledge exercise. That's what we're doing. It's collective applied epistemology. Yeah, I think I got that one right. That sounds good. Just drop that one into a meeting sometime. Yeah. So what are we doing here? Collective applied epistemology. Wow, that's pretty cool. Nobody will ask you what it means. Then say, therefore, our software development process is by definition a knowledge acquisition process. That is what you're doing. You are learning. Okay. So if you're talking to somebody who's kind of like C-level, then use knowledge acquisition because it sounds formal and fancy, but the rest of us just call it learning. That is what you're doing. Software development is an act of continuous learning. Okay, what you're doing is like, oh, okay, now I understand that detail. I understand the significance of it. Oh, now I understand something about that framework. It's both outward and inward looking. And if you knew everything at the beginning, then there's not going to be much development. That's the whole point. You are, by definition, working with incomplete knowledge. And that brings us to another conclusion, that software development is mostly about working with incomplete knowledge. Now, that's not actually a problem. It turns out that human beings do this all the time. You did it this morning. You're doing it now. You don't necessarily know what's going to happen next. Okay? And that's okay. Where does the problem come? The problem comes from illusion. The problem comes when we believe that we have complete knowledge. It is the illusion of complete knowledge. Now that one completely bamboozles us. It's just like, once you think you know everything, oh, now you have problems. Yeah? But if you have that kind of humility, oh, I don't know everything, but I know how to find out. That's the trick. It's the second bit. So you're constantly learning, and you're formulating it and trying to put it in a codified form, quite literally. So this set of assets is valuable from that point of view. It's kind of like an executable Wikipedia. Now, here's the thing you're trying to do. You're trying to communicate. And therefore, it's an act of communication. The very act of writing code, the very act of writing a test, the very act of describing the test, having a stakeholder and a coder sitting next to each other, describing that is an act of communication. And what you're literally trying to do is codified an understanding. And that may itself be iterative. So this idea of thinking of tests rather than as confirmation, but as acts of communication, that suddenly changes the shape of everything. Coding guidelines, they are about communication. These are suddenly, oh, okay, this makes a lot more sense. Now, this also has some other interesting consequences. It basically means that unless you're developing on your own, software development is by definition all about social negotiation. That's what coding guidelines are. They're not about what is right. There are some things that are worse than others, we can definitely say. But most of the time, they're not about what is right and what is wrong. It's a social negotiation. It's about the compromise. It's about the understanding. And sometimes you have to poke it to find out that it's there. Now, this has a really interesting consequence for the code base. It means that the code base, its structure, represents a model of participation. Now, this is interesting because when we normally talk about software architecture, we normally think in very structural terms. And the term architecture does suggest that. But the thing that people often forget about the architecture metaphor when applied to buildings is it is not just about the structure. A good architect is trying to work out how people are going to use the space. That's what defines the good architect. It's not just something that's good to look at. There's actually a term for that. It's called magazine architecture. Yeah, it's used in Stuart Brand's book, How Buildings Learn. Magazine architecture looks great in a photograph. Yeah, and you've seen it in code as well. That normally comes up in demos when somebody's trying to push a product at you. So that's normally magazine architecture. It's just, this is fantastic. And Stuart Brand talks about his book. He says this book's dedicated to an architect I once met who definitely epitomized this idea of magazine architecture. He said, do you ever go back to the buildings that you designed after handover? And he said, oh no, it's too depressing. There are people in there. And there's a point here that a good architecture is not simply a structure. It is a structure for how people work, how people communicate, how people go through their day, how they live, how they work. The same is true of code. Your architecture is a model of participation. You're basically saying, with this tooling and these arrangements and these conventions, this is how we as a team do things. There's a representation there. So this leads us to something kind of interesting. Instead of focusing on speed, what we're actually doing is we started with a very simple dimension, but now what we're going to do is we're going to move out. We've actually seen that there's a reflection of who is building and how. So I made this observation in an interview. The biggest advantage of autonomously working teams is risk reduction through increased group intelligence. So that's what you're trying to do, is group intelligence. You're trying to enhance group intelligence. Now this is quite important because there are some very naive ideas about how intelligent a group of people can be. So there's little correlation between a group's collective intelligence and the IQs of its individual members. This is one of the most important things. Okay? Britain, we call this Parliament. You can have a group of smart people. Actually, no, we don't call it Parliament. Honestly, some of them are really thick as anything, based on some of the stuff they're saying. Yeah, it's just... I mean, we have a Minister of Ignorance and Misinformation, a guy called Chris Grayling, who managed to outsource a ferry contract to a ferry company that didn't exist. It's cost the government £33 million to figure that one out. And if you're wondering how much £33 million is worth, just wait a few weeks, it'll be worth a lot less. It might reach parity with the Aussie dollar. So, but it turns out this guy, Chris Grayling, the biggest news, his birthday is the 1st of April. Why did we not know this before? Why did we not know this before? We would have understood. That makes a whole load of sense, more sense of the last 10 years of British politics. But here's the good news. If a group includes more women, its collective intelligence rises. Now, I'm looking out here and I'm saying you could be smarter. Okay? I actually, it was kind of interesting after reading this, because this was not the result that they set out to explore. But it was quite interesting after reading this. When I ran workshops, sometimes I try and make sure that I don't give a team an unfair advantage. Because I've noticed, I had this last week because we did a random selection, I had this last week, I had a team of all women and yeah, they kind of clean the floor with the rest. So, some of this is anecdata, but I've been doing this since about 2011. Every now and then it's just like, yeah, it changes the communication dynamic. And this is actually a broader observation. People from diverse backgrounds might actually alter the behavior of a group's social majority in ways that lead to improved and more accurate group thinking. Now this is really interesting because now we're suddenly going right back to this idea of what we're trying to do is an activity of knowledge. It is this, and so therefore if you're all thinking the same, you're not really thinking. And that we have, and this I noticed with a friend of mine many years ago. He ran a startup and hired the smartest people. Turns out that's not what he wanted. He needed to have the people that work together best. And working together sometimes means a little bit of give and take. You don't want toxic, we're not talking about get lots of toxic people in because they'll think differently. No, that's just scorched earth policy. We don't, no sociopaths here, thank you very much, we're good. But what you end up doing in many cases, if you're not careful, is you recruit in your own image. And I noticed this in a company in London years ago. I was doing a craftsmanship program for them. And they're a financial company, but the group that I dealt with were all ex-games industry. Now, I found that absolutely fascinating until I realized that the person who set up this group Actually, I can say man, because they were all male, because I don't know if you've had experience with the games industry, but yeah, particularly console games. And then recruited other programmers he had confidence in. Well, which domain, and obviously I've worked in the financial sector, and no disrespect to anybody who works in the financial sector, but you know, that's a keyboard, this is a compiler, because sometimes there's a huge range. There are some brilliant people, but there's some people at the other end of the bell curve. And I'm not talking about new people. This is not a measure of you are new. This is something else. But that's why this guy, he said, okay, who are the people I know who've really got the coding chops? Gamers. These guys, they know everything. And it turns out all you do is you feed them coffee and pizza and they go for 24/7. It's fantastic. But the problem is now he had a groupthink. The opposite of group intelligence is groupthink, where you are all kind of, it's like soldiers marching across a bridge. And yeah, if you're all marching in step, it turns out the bridge collapses. Okay, sets up the wrong harmonics. You need to break step. You need to do that with people as well. So this is a very difficult thing, is to recruit people that are not like you. That's very difficult. Yeah? We understand why humans have this kind of draw, but this is really important. And therefore it changes the communication style, given that what we're trying to do is communicate and capture that communication and to question things. It's this idea of being able to question things. So this is the key thing. And this idea of the wisdom of the crowds, go back to 2003, James Surowiecki's book was really rather good on this one, because he said you can't just get a bunch of people together. There's basically 4 conditions if you would like to have not just a bunch of people, but have a wise bunch of people. Then you need diversity of opinion, independence, decentralization, and aggregation. In other words, you can't all think the same thing. Independence is independence from influence from one another. This one's actually quite difficult to achieve in many cases, but you know, it's aspirational if nothing else. The idea that you are not just going to be easily influenced. One of the things we've learnt in politics is that families and friends have a very great deal of influence, so you're not actually necessarily thinking independently. And decentralization is drawing from different sources. You draw your knowledge and your experience from different backgrounds. So you clearly need something in common, but you need to have something that is different. And this is interesting when we start talking about disciplines that people are recruited from. So, you know, it's, computer science education is one thing, but it's always kind of interesting when you get, you know, the people I've met who have left a very strong impression on me have come from, in terms of software development, politics and history. That's an interesting background. Guess what? You start looking at software and organizations from a very different point of view. Okay, it's fundamentally a different perspective. You ask different questions. Linguistics. A linguist, what are they going to do? Well, kind of language, kind of communication, kind of what are you actually saying? This whole approach, their approach to programming languages, is also fascinatingly different. They engage in it in a completely different way. And so this idea of, otherwise you do end up with this kind of monoculture and everybody is marching in step. And clearly you need some of that knowledge, but you need that decentralization as well. Now, all this is great, but you kind of need to put it back together again. You know, otherwise you're kind of a bit like me, was just like, yeah, I'm taking the washing machine apart. Kevlin, you're going to put it back together again? I have no idea how to do that. Okay, you need to put it together again, because otherwise you don't get that knowledge. You end up with people wandering off in independent directions. And aggregation, where does aggregation occur? It happens by the water cooler, it happens in the code base. Your code is a codification. It happens in conversation, it happens in documentation, it happens in all of these things. So, when we talk about speed, there's something else that normally goes in there as well. Because people tend to put this, and there's another thing that people like to throw around. Size. And when the word size comes in, particularly in the Agile space, people are talking about scale. We've got to scale this team. We've got to scale the development. One of the most interesting questions, and as I like language, I'm always looking at the words that are not said. What are the words that are not said? Because if you come at this from a different point of view, it turns out that you can put the word up afterwards, but you can also put the word down. we've ended up with the default of assuming it's always up. Now, my older boy, for a couple of years he was doing CrossFit. Really interesting. In CrossFit, there is a concept called scaling. And scaling is where you scale down an activity, an exercise, because perhaps you're new to it, perhaps you've sustained an injury and you can't do the full exercise, but you want to do the repetitions, so you reduce it in some way. Okay, you simplify it, you reach less, you use less weight, whatever it is, you do less of it, but so that you can still go through all the motions and still make progress. But the most important thing there is that they don't say scale down, they just say scale. So there's this point of what are the things that are not said, and that domain of defaults is in exactly the opposite direction, and that is the question you need to ask. Okay? So it turns out that scale matters, you know, there is an appropriate size for various tasks. You know, if you're going fishing, I would suggest this one is probably a better deal than that one over there. If you're trying to, you know, pollute the planet, probably the one over there is a really good one. You know, so. But an observation from a friend of mine, Alan Kelly, he said software development does not have economies of scale. This is quite important because where we're going with this one is we're going to challenge a couple of other things, because economies of scale are kind of built into the manufacture of physical goods. Reduction of marginal cost, it's great. It's going to, if I have to build one of these things with this stuff, it turns out that building 10 of them will not cost 10 times that. You know, if I've done things right, I've bought in bulk, I've got the same, I've done all the learning up front as to how to do this. Now it's a simple case of manufacturing and reducing those costs. That's great, and that does work with physical things. And that's our instinct because we are physical creatures. We're anchored in the physical world, so it's natural that we derive our experiences and our intuitions from the physical world. Problem is, this is a knowledge-based activity. And it turns out that the more people you start adding, you don't necessarily automatically get smarter and faster. Yeah, and be very careful. I'm not saying adding more people always slows down, but it is worth understanding how this grows. So we can do a little bit of first principle stuff here. T equals T1. Oh, we're back to the equations. Yeah, we'll start with something simple. This is the amount of time that it's going to take one person to do all the development work. And when I say all the development work, I'm talking about the coding, I'm talking about the requirements, I'm talking about absolutely everything. Software development in its broadest sense. This person is cross-skilled, the rest of it. So that's our baseline. Somebody comes along and says, haha, I have read Adam Smith. Division of labour. If I get 2 people on this, it'll take half the time. Get 3 people, take a third of the time. This is brilliant, it's fantastic. But we have not talked about the nature of the work, because it turns out things start getting a little bit messier here. How much can you actually do in parallel? This is now starting to tell you that you might have to wait in certain cases. This is the shape of your process. If your process introduces lots of wait states, then you will not be able to have everybody working simultaneously. That doesn't mean actually that they're going to sit there waiting for it. It means that in order to look busy, either they or the organization will give them other work, which has to be timed perfectly to fit these gaps of availability, and actually it won't be timed perfectly, so there's some fascinating knock-on effects. It turns out this is one of those classic things. The lean people, the Kanban people have this absolutely right. Okay, reduce the work in process, but you are now going to reduce the amount of work being done. Now, we actually have a name for this, it's called Andar's law. We normally apply it to processes rather than people. And at this point, it allows me to issue a disclaimer. This is a thought exercise. People are not interchangeable. So when I use N, I'm not, you know, we need to understand this is a thought experiment, and that we're not going to get smooth curves out of this. It's going to be messy because we're human beings, okay? But we're getting a rough idea as a thought experiment what's going to happen. But we're not done yet. Yeah, 3 levels of bracketing. Fantastic. I had to dig up a maths book to remember what the ordering was. Wow, what's going on here? Well, it turns out the shape of your architecture, remember your model of your model of social participation? How do you talk to each other? Who needs to talk to one another? In the worst possible case, everybody needs to talk to everybody else or communicate. That could be verbal, that could be dealing with their code. It means potentially everybody is stepping on everybody else's toes. and that there is a cost for this. There is an overhead. Now, what is interesting about this is, and you're sitting there going like, oh man, it's too late in the day for me to deal with equations. Let me draw you a graph. Right, okay, there we go. What this tells us is, if you have 0 people, it takes infinite time. Okay, are we happy with that? Yeah? But no bugs. Winner. And then you start adding people, and for the appropriate task, you start getting a speed up. Yeah, we're getting about the right number of people for this, and yes, this is good. We're at an optimal level in terms of the code, the people, and so on. That's great. And then you start adding people, and it starts slowing down, because now what you're dealing with the effects of having lots of people. You're not talking about the code itself. You're not talking about the nature of the software. What is absolutely fascinating is that this tells you that beyond a particular point, the number of people involved in development has nothing to do with the amount of functionality that you're trying to implement. And there's this kind of idea of, oh, it's a bigger system, meaning big functionality. This becomes a self-fulfilling prophecy, because what you end up with is, well, we're going to have a big system. Well, how big? Well, we're going to put 50 people on it. Guess what? You're going to get a 50-person system. It doesn't matter if it's Hello World. You're going to get a 50-person Hello World. And man, the architecture of that's going to be something else. Because that's what will happen, is people will create that nature of work, and depending on the culture there, sometimes I've seen this where you defend against other people's code. There's a sort of distrust. Well, I came from that team. Because our team is so large, we have to have sub-teams and sub-teams and sub-teams. Okay, we don't trust code from them. Just check those arguments again. I know they said they weren't null, but you never know. And it's just like, all of this stuff. And so what you end up with is it creates itself. And so there is a cost to this. I might suggest that many consultancies operate on the right-hand side. It becomes self-fulfilling. So you end up with kind of stuff like this. This was from a couple of years back. Facebook iOS app has over 18,000 Objective-C classes. I did this as an estimation exercise a couple of years back. I got somebody, I said, okay, you got the iOS Facebook app, and I said, I use Android. I'm probably sure it's probably the same. I can't imagine it's going to be different. How big do you reckon the code base is? And one person did actually say 18,000, but they said lines of code. And I can tell you these are not one-liners. Now, here's the interesting thing. You're thinking, what is it doing other than stealing my soul? And, what is it doing? And sometimes we go, oh, it's all the analytics. No, those happen at the back end. This is what's sitting on the phone. It's just like, wow, that's pretty serious. But the thing to look at is, turn it around. Could you create a small code base with 400 people? I think it'd be almost impossible. Actually, there is a way. What you do is you say, right, well, we've got 429 there, so 400 of you, have a holiday. You 29, get to work, and you're probably going to end up with something that's about the right size. Yeah? But there is this possibility to turn it around. It is almost impossible to create a small system with this and the communication structures that are involved in that. So the environmental economist Ernst Schumacher made this lovely observation. For every activity, there is a certain appropriate scale. And we need to find that. This is important because, and I'm going to go back to the fact it's not a perfect graph, it's not perfectly smooth, because sometimes people say, oh, well, it's easy, you just add a person and it slows down. It's just like, it's not that easy. It's all a bit kind of trying to go up, it's trying to walk across terrain in dark fog. You're not entirely sure if you feel we're going up, but it might just be a local up. You don't know, okay? So there's a little bit more to it than that. But normally I would suggest starting on the left-hand side and scaling up. Then you start noticing the differences. You might find, and I actually did work for a project manager who did scale down. It made him desperately unpopular because it was successful, okay? And he halved the team size, and it worked. He was, absolutely classic. He was brilliant to work for, so they got rid of him. There you have social, well, because he wasn't playing like the other kids were playing. He was doing things like, why is this? Asking questions and stuff like that. And everybody else said, no, we're all middle managers. This is the sport we play. Question?
You started out with an equation called Abdel's law.
Yes.
And then you modified it. What's the larger equation called?
That's connections. That's the...
What's the whole thing called?
Oh, I have no idea. This is some kind of scaling equation. I don't know. I just sat down and worked this one out from first principles.
Cool. Can we call it Henney's law then?
Yeah. Now, I was just thinking if it clashes with anything else, because there's a Henney's hypothesis that was that somebody coined, but yeah.
The reason I bring that up is I'm interested in the variance of the team size over time. Like if you start with a small team and you give the team itself the autonomous ability to scale, that's going to work far better than anticipating the team size at the beginning, right?
Yeah. This is important. There are other terms, and I've kept it simple because, one, I'm going to run out of slide, and two, we start speculating a lot more. We're just getting a rough sense. But that's exactly right. What you want to do, as I said, that's worst case. What you want is teams of autonomy, and that idea starts working differently. But we start diverging from this equation to something else. So what I've done is I've showed you what happens if we don't try. Yeah, if we just do default behavior. And hence that comment about worst case. Yeah. In a good case, you do actually end up with much more localization. Yeah. And so there'll be two factors there, not just one. Yeah.
Thanks.
Yeah. It's left as an exercise for the reader. There you go, that's your homework. Right, so let's go back to this question of scale and understanding how things might work. Going back to the 60s, 1964, notes on the synthesis of form. You know, it's one of those things where you get the sense that Christopher Alexander never actually used this phrase out loud because it's quite difficult to say. But it's often just referred to as notes. He's the guy who came up with patterns, design patterns. So, and I had this, this is my copy of the book. I read it in the 1990s and then referred to it again recently and was surprised to discover how influential it had been in the 60s. And he's talking about creation of structure. We may therefore picture the process of form making as the action of a series of subsystems. This is subsystems of code, or subsystems of people, or subsystems of anything, all interlinked yet sufficiently free of one another to adjust independently in a feasible amount of time. It works because the cycles of correction and recorrection which occur during adaptation are restricted to one subsystem at a time. What he's talking about here is you don't want to be too close to everybody, but you don't want to be too far from everybody. In other words, you don't want everybody acting in unison, but you also don't want people to be utterly fragmented. He's looking at this happy medium. It turns out people were very keen on drawing, so he drew this kind of diagram to represent it. Here is our team, or here is our code. This is a subsystem, and it has loose coupling, so it can adjust to something else, whatever that other else is. But it turns out people were really into drawing circle diagrams in the 60s. This is from 1968. Similar ideas, but this one comes from a famous paper from Melvin Conway, How Do Committees Invent?, from where we get the term Conway's Law. And his observation back in 1968, the basic thesis is that organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. Now, we talked about communication, and there's this idea of once we understand the knowledge flow, then this kind of makes a lot of sense. Why would people do something that was not related to how they related to other people? It's very difficult to work against that. It's not that it's impossible, it's just that exerts a major force. He also made the observation, we have found a criterion for the structuring of design organizations. A design effort should be organized according to the need for communication. Now, this is important because sometimes people think that this is just a consequential thing and that he didn't see past that, and people have tried to create new things called the reverse Conway maneuver and inverse Conway and stuff like that. It's just like, no, it's called Conway. It was in the original paper. It was actually his observation is, given all of this, we get to change this. And this was something we explored in Poser 5. We looked at a bunch of things on patterns. And we talked about this. We're referring to this as a law. The appeal is to a force that will shape a system. So the force is always there. You don't get a choice in whether or not it's there. It's a physical law. It's not a law that you're following. It's not like the laws of the land. We use the word laws very loosely. And I intentionally annoy my wife by saying that rugby has rules, whereas it has laws, and my wife is into rugby and I am not, so I often just come in and make inappropriate comments. It's Six Nations at the moment. Generally make inappropriate comments about that's a handball or something like that. And looking at the players, they've got too many players on the field. Yeah, you need 11, they've got 15. What are these 4 spare guys doing wandering around? Yeah, and they keep touching the ball. The ball's the wrong shape as well. So I do this to wind up. Do they not have rules in this game? No, Kevlin, they have laws. Well, clearly not very law-abiding, are they? So it's none of those law systems. But there's an interesting thing here. it's not a law that can be broken, the force is always there, only one that can be counterbalanced by other forces. Now that actually brings to mind something else, which is kind of interesting. There's a four-force diagram that's often used when describing aircraft. How is it that aircraft defy the laws of gravity? They don't. Yeah, because I've had this observation with a couple of people say, oh, our methodology, we don't believe in Conway's law. That's great. I don't believe in Father Christmas, but that doesn't actually make much difference. This is actually a real thing. It has been measured. But also it doesn't eliminate it. What you do, you don't get to eliminate gravity when you fly on an airplane. What you do is you bring all the other things into play to allow you to balance it, to get lift. So, and obviously don't take the next diagram too literally. This is a physical diagram. I'm dealing with people and code here, but it's a kind of a useful, rough idea. You could say, well, hang on, do we have things that we are trying to balance? Well, yeah. You know, our design effort should take us forward, but technical debt can hold us back. That's our drag. That's the friction from the air. That's the friction from our attempt to progress. Conway is a defining force, but it turns out that our practice can move against that and balance it. But it takes effort. It takes work. But that's fine. It's just that if we realize this, we're not eliminating stuff, we're bringing things into balance, which tells you it's a little more delicate. It's that kind of fine-tuning. How do you fine-tune? Well, might I suggest the PDSA approach is quite a good way, because there's adjustment, constant adjustment. It's like you get in a car, even if you're given a straight road, you don't just take your hands off the wheel, I hope. Yeah, I've set the car on the roughly the right route. Yep, let's go. No, you keep your hands on. Okay. What we're talking about here, interestingly enough, takes us back to equations and finally starts giving us an answer, because we're dealing with forces. So what's M? M is the mass of stuff. It turns out that you might be applying a lot of force but not getting much acceleration. You've got lots and lots of people. We are applying immense amount of effort, and yet we seem to be making very little progress. M is for mass. M is for monolith. M is for the stuff that stands in your way. It turns out, when I said the comment earlier on about the agility of code, I was being fairly serious. Why the size of the code base matters. It's not because I care about exact lines of code, but if the intellectual task that you're trying to do is orders of magnitude larger than it should be, that's a cognitive load that every individual has to bear. That's what they're going through every time they're dealing with code. That doesn't mean they can't do it. It just means they're going to slow down. That's going to affect it massively. So these things are big. They're old. What you're seeing here is one of the next generation. They're trying to, in the hope that Brexit will bring new hope to British industry. This is one of the computers they're rolling off off the line. It does something to do with date calculations. We're not quite sure. It's a legacy system. This is the best we can do. But but what we're talking about here is monolithos, one stone, monolith. And obviously, this is where we start talking about good design. We want stones to be arranged like this. We want it elegant, well thought out. And this is when my youngest son was about 5. He arranged this and managed to get some seaweed. It's got a really nice sort of Japanese aesthetic going here, but I wouldn't recommend eating it. It's just like, oh, this is really good. And normally at this point, somebody says, he's talking about microservices. Honestly, if it makes you feel good, yes, I'm talking about microservices. But I could have been talking about components, I could be talking about objects, I could be talking about well-partitioned function hierarchies. What I'm talking about is breaking things up, decomposition. And we're not decomposing just arbitrarily, it is so that we can understand. It's so that we can compose, so that we can communicate. But the sad truth of many microservices and many architectures is they end up looking like that. There's our elegant microservice architecture. What do you think of it now? It turns out that that's not enough. You cannot simply say that's it, because you are dealing with the system of people. You are dealing with all those other forces. Simply saying, here's our default technical architecture may not be sufficient, it turns out. You have to bring everything else into play. So the old observation from Alan Perlis, in the long run every program becomes Rococo then rubble, doesn't change. To create order, you have to put work in. And all of this is this careful deliberation that gets us away, and you'll notice what we've done is we've moved away from an obsession with speed. But I want to bring all of this back to why does this make a difference? When people start talking about all these practices, but to make that agile work, the way you're describing and to do the coding practices and to make sure that we've got clean code, to make sure that's going to take a lot of time, it's going to take effort, it's going to slow us down. So I will end with this observation. It's an observation which is interesting because why do cars have brakes? Has a simple and obvious answer that is also correct. Cars have brakes so you can slow down. But there is another answer that is less obvious, but turns out also to be correct. Cars have brakes so you can go faster. Think of it. If somebody says, hey, this car, the brakes don't work. Do you want to go for a ride? There's a really simple answer to that one. The word no springs to mind. The words, I'm fine, I'll walk. Those, there's lots of options here. But that's what it takes. There's that idea. And in fact, this is one of those, I've been talking about thought experiments. Let's talk about real experiments. There's a guy, I don't know him anymore. I don't even know if he's still alive. You'll understand why I have these doubts. It's nearly 30 years ago. And a guy called Alan, he drove from London to Brighton, which is about 100k, in a car that did not have a working foot brake. It took him hours. Even with bad traffic, which is normally present, it should only take you a couple of hours. It took him about 4 or 5 hours because he was driving, he was using back roads, light touches of the handbrake, careful gear changing to regulate his speed. And it's just like, and honestly, I've been in a car with Alan twice on other occasions, and that was with brakes, and it was quite scary. So this is why I don't know if he's still alive. But he did this experiment years in advance. There is a point here. Many of these things, many of the things that people say, oh, but to do that will slow us down. Yeah, that's fine. Honestly, speed is not the issue. If you want to be able to turn a corner, it turns out that being able to brake is helpful. If you want to respond to the situation at hand as it develops, as you discover new things, as the world changes around you or within you, you have new knowledge, you have new team members. The point is you want to be able to respond. It's that ability to move easily. And that also is reflected in the code base. If you have a whole load of code and you say, we're going that way, and the code goes, no, we're actually going that way. If the code base has the veto, you lose. It's as simple as that. I showed a picture of those ships earlier on. I think I learned a few years ago, an oil tanker has a turning circle of around 5 kilometers. Okay, that's not a skateboard. Okay. Oh, we're going in the wrong direction. I left my keys at home. Oh, I left the cooker on. Right, okay, you need 5k of space in which to turn. And there's a lot of systems that are like that. So it turns out that matters. Right, okay. I'm going to say I'm done. No, I've run out of slides, but I could talk about this for hours. Thank you very much.
Thanks for that, Kevlin. It's really great. Do we have any questions? I'll just get everyone to shout them out if they...
Questions, thoughts, reflections? Yes?
Yeah. What are your thoughts? Well, 2 questions. One, do you hate the word sprint, seeing as you have something of a focus on linguistics and sprint?
Okay, let's handle that. Yeah, do I hate the word sprint because of the focus on linguistics? I do a little bit. It's historically anchored. And I understand its historical relevance because at the time, Scrum is very old. It's a lot older than people give it credit for. It goes back to the early 90s, basically. And at that point, if you use the term iteration, then iteration typically referred to a period of months, plural. So by default, when somebody says we're doing iterative development, you might be working in quarters of the year. Yeah? Whereas at that point, Scrum was, it wasn't at the 2-week mark, it was saying basically 30 calendar days. And so they wanted, naturally enough, to use a verbal distinction. And there was another implication with sprint, is that it's focused. It's a straight line, it's focused without interruption. That one seems to have got lost somewhere. That was the whole idea. If you read all the original Scrum literature, it's without interruption. It's just like, right, I've started the race, and your choice is, and you can see this in 100-meter competitions, your choice is either you run to completion or it's cancelled. There's a false start somewhere. You're supposed to be able to cancel sprints. That one got lost in history as well. So we have that, but it is worth understanding, so these days when people talk about sprints, and if people don't know the history, often people, and I know of one case where a team said, well, we've stopped doing iterations, we're now doing sprints. Why? Because they're faster. It's a little bit like back in the 1980s, there was a fashion for putting go faster stripes on the side of your car. Had no effect on the aerodynamics of the vehicle, but it made it look like it was going fast. So I do know of a case where that has misled us at least once, and so therefore, yeah, we have a little bit of a linguistic problem there.
The follow-up was, well, I guess the main one I can think of hating sprints is David Hansen, who goes on about it a lot, the CTO of Basecamp.
Yeah.
And I was wondering what you thought about their model where effectively they work in, I think it's about 2 months, with 6 weeks of work, then kind of 2 weeks rest and reflect, and then another 6 weeks, and they work like that as opposed to continual sprints.
Yes. Now, what is interesting there is that what this is curious because that the original sprint model, again, I'm going to go back to early Scrum, was you had sprints and then you took a break, and then you had a sprint, then you took a break. Again, that got lost. It's back-to-back stuff, which if you're going to take the metaphor seriously is exhausting. Okay, you've just run. Oh, yeah, that was a good sprint. Okay, do another one. What? Come on, give me a break. So yeah, that idea of notice that idea goes right back to what I was talking about in the same logic as the PDSA cycle, the same ethos. That idea, you need to breathe, you need to study, you need to take a break. You cannot be 100% on, because for a lot of people, what Scrum without its sensibility has ended up meaning is a series of perpetual deadlines, and they're permanently stressed. Rather than permanently stressed about one big deadline, they're now permanently stressed on a monthly or fortnightly basis. And so there's this idea of you do something and then you take a breath, you take a breather. If you're going to use sports metaphors, then use sports metaphors. You're going to take a break after it, yeah? Otherwise shift to a different metaphor. Yeah. Yes?
At a kind of a higher level, one of the big pushbacks against Agile is the so-called business reality of needing to estimate time and money on projects.
Mm-hmm. Yeah.
And I was hoping to hear your thoughts on what can you do to more effectively counter that idea and demonstrate that you can get better business value out of doing something agile instead, and alternatives for dealing with like costing issues and time engagement.
Yeah, right. There's no one single answer to this because different organizations behave differently, they have different cultures as to what they want to do with the numbers. And that is huge. When somebody asks you for an estimate, you want to know what they want to do with it. You want to know why they're asking you the question. The reason I say that is because I was in a situation where I did a thing for a company. It took us 5 years to set up the workshop on agility. I just want you to think about how agile these people are. We need you to help us improve our process. It took 5 years. But the good thing is we managed to get everybody in and to review and go through their practices and explore the way they did things. And when I say everybody, I mean we're not just talking developers, and testers, I'm talking about the product owners as well. It's so rare to be able to draw them in. This is great. But what was fascinating was one of the conversations that came out when one of the developers was pushing back against the estimates and the precision and all the rest of it, and one of the product owners said, "Oh, I had no idea that you were doing all of this. That's not what I want." The reason I want an estimate, so this was the interesting thing, is the motivation, is I want to know roughly what order of magnitude. We're thinking, yeah, these are my words rather than his. He says, I want to know when I ask for this, is that something we can slip in a couple of weeks, or is it going to take a year? I don't actually care if it's 2.5 weeks versus 2.3. He says, I want to know if it's weeks, months, or years. He was just after T-shirt sizes, orders of magnitude. It was as simple as that. So that's the reason, that's the first thing whenever anybody wants an estimate, is you have to understand what they're asking you, why they're asking you for it. Because they'll say something about planning, but that doesn't mean anything. Because what kind of planning are they doing? Are they doing rolling wave planning? Who's pushing on them? Who wants these numbers? Find out how the numbers are going to be used, and that will tell you what you're offering. Second thing is, you've got to converge, which is why these cycles are important. And the convergence thing, it becomes a negotiation, an ongoing thing. It can't just be a one-time affair. You can't just do it once a year. You have to. This has to be part of the process, which also tells you that when it comes to this question of, going back to what I said, you can't estimate by business value, but you can estimate by prioritized business, by an estimation. You can't prioritize by business value, you can prioritize by an estimation of business value. The point there is that that becomes a proper conversation where you're actually asking somebody else, you need to calibrate this as well. Rather than saying, we're marketing, we know. No, you don't. Honestly, you have absolutely no idea. You can't say that to them, of course. But I'll give you a very simple example of the fact of how wrong numbers can come out. So let me think. Avatar. That cost just over $250 million US. That was 2009, and it has broken the $1 trillion mark in terms of its revenue. Okay, that was a, that was. Have I got my magnitudes right? No, $1 billion mark. Thank you. It's broken the $1 billion mark. That's a good investment of $250 million. Then there was another film, came out 3 years later, that also had 3-meter-high aliens and was set on another world and had a protagonist who basically went native. And that was John Carter. It wasn't a terrible film, but it did cost the same amount. And they still haven't made that amount back. Now, I do not imagine for a second that there were film executives sitting there going like, yeah, this one's going to stink terribly. It's going to bomb totally in the marketplace. Let's fund it. And the point there is that they are the business people who are supposed to know. So therefore, there is this idea that there needs to be a calibration. So when somebody says, we are the business, therefore we know, no, you don't. No, or not necessarily. You can't come back with a contradiction. Not necessarily. So you have to work towards that, and that gets you the agile bit, which is now suddenly you're talking. And you're saying, well, okay, how much, you prioritized this last time, how's that working out, and do all this stuff. And suddenly, that's what's, now you have all of those lovely little feedback loops in there. That's the road to progress. Normally the problem, and I can't say it's going to be easy to crack, but normally the problem comes about from an us and them, and then we believe something about them, they believe something about us, they believe something about the marketplace, they're not necessarily in a position where they can learn. This is where the culture question comes in, is actually, are they being encouraged to do the right thing, or are they feeling the pressure, which then gets passed on? Yeah. So that's why there is no one answer. But it turns out that there are ways of kind of teasing this out. Yeah. Okay. Any other questions, thoughts? Right. Well, thank you very much.
So, yep. Thanks again. Way to come to speak to us here in Perth, and hopefully there's a UK there when he gets back.
Who knows, you know?
Thanks again to Bankwest for coming to party and supporting us once again. And I'd also like to thank the DDD people for helping us set up today, and also Dave back and forth.